Thank you so much, guys. And thank you guys for joining me here. So, I am here to explore a simple but powerful question. What if your Django app could actually defend itself and get smarter over time? And that is actually what AI WAF is all about. It's an open source Django native firewall that learns from real web traffic. Now instead of just catching 4 flood, it can also catch probing attacks, subtle issues like UID tampering, and get smarter over time. Now, by the end of the session, the goal is to not only understand how it works under the hood, but also how you can apply it without really needing a dedicated security team. So, before diving into what AI WAF actually is, I'll introduce myself. So, I am Aayush Gauba, and I'm a student and researcher at Southern Illinois University, Edwardsville. Now, my academic focus is quantum inspired AI algorithms, which is basically how you can use principles from quantum computing to inspire new architectures for machine learning. Now, outside that research, I'm also very passionate about applied security and open source projects. Um, and I think security today is a necessity, not a luxury. But the problem really is there's lots of bad actors constantly probing for weaknesses, and the most vulnerable organizations are often the ones with the least resources. Now, that often includes nonprofits, small businesses, for which enterprise level solutions might be very expensive and complex, which might put it out of reach for these groups. That's why I think open source security is so important. It levels out the playing field, giving smaller organizations a fighting chance as big as the big players, without really the barrier of cost. Now, as we all know, open source means transparency and collaboration, and the more the people get involved, the more the tools get stronger over time. Diving a little more into why security needs to be open source. Now, the thing is with security, there needs to be a community audit, and without community audit, you risk bugs or misconfigurations, or sometimes even unintentional backdoors can go through unnoticed. By contrast, when you have open source security tools, they are more transparent, peer reviewed, and customizable. Now, because of inherent open nature of open source, that means anybody can test these systems and contribute to improvements. And security really needs to be a community effort, and the more people contribute, the more stronger it gets. And it also gives smaller organizations and nonprofits a fighting chance. So the main thing in this presentation is how AI WAF actually works under the hood, the method it uses to validate requests and also detect anomalies and block malicious traffic. Secondly, I'll also show how easy it is to plug AI WAF into your own projects. The idea is not just to make it theoretical, but something you guys can take away from this and apply directly. So this is a middleware level security. It's You can add or delete parts of the middleware as you want to. So I'll be going into how each middleware works, middleware by middleware. Now onto the header middleware. Now, as the name implies, now the main goal of this header is to inspect the headers of every incoming request. Now, legitimate browsers have a consistent set of headers, but when you have bots and scrapers, they often reveal themselves with missing fake or strange headers. Now, when you validate this early, we can block bad traffic even before it ever reaches the app. And instead of just blocking if one thing is present or not, this system actually combines scoring model to make decisions. Now, the validation basically works in layers. First, it checks whether basic headers like user agent and accept are present. Then it looks at the user agent string for known malicious keywords like you have a Python request and then curl wget or maybe fake Mozilla strings. Then it uses a combination of headers that don't actually make sense, like an old browser with a modern protocol, and then it calculates a quality score based on header completeness. Now, if the score is too low, the request is considered outright suspicious and blocked. Now, in practice, what this really means is that your normal users and your trusted bots, like the Google bot or Bing bot, the actual search engine scraper bots, actually pass through. But when you actually have malicious scrapers or outdated scanners, they get blocked with a 403 forbidden. And the response is returned as a JSON with a clear error message. This way, your application stays secure without wasting any resources on bad request. Now, this is actually what will catch 90% of bad bots, scrapers, and sometimes even vulnerability scanners. And I'll dive into a short example to show kind of how it really works. So let's assume we have these two requests right here. The first one is the kind of request that you would see for a static style sheet, and the second one is actually a malicious request. Let's kind of deep dive into how different those two requests are. So this, if you look at this log entry, this is a normal static file request. The IP shows us who made the request, and the timestamp shows when it actually happened. Then the request line is a simple get for a CSS file under the static, which, as we all know, browsers do when they need when they load style sheets or fonts. The response is 200 OK, which means it succeeded, and it was 44 bytes, which is kind of what you would see for a small style sheet. Now, the referrer field shows that the request came from a page on yourwebsite.org. Now, your website is a fictional site if that exists, and this is actually not from that. And So everything else makes sense. The user string also matches a legitimate Chrome browser on macOS. Finally, the request completed in just 35 milliseconds. Nothing kind of suspicious here. This is the kind of traffic that AI WAF would be let in through without interference. Now, this is what it looks like when AI WAF would actually step in. The attacker IP is trying to access webadmin.php, which is a common target for automated web scanners looking for misconfigured admin panels. Notice the request is missing basically two things, a user agent and a referrer, which makes it even more suspicious. Now, instead of giving them a clue by serving a 404 or worse, AI WAF actually blocked it with 403 forbidden. The response was only 31 bytes and completed in 54 milliseconds, meaning the attacker got actually nothing useful. This is actually the value here. The bad traffic is stopped even ever before it reaches your app logic. Now, IP and keyword middleware. So this was the first middleware that was actually developed. IP blocking and exemption is actually now in every middleware. Um, So in this particular middleware, it starts with an IP check. If an IP is blacklisted, it's blocked immediately, and if it's exempt, it's allowed. To be extra safe, exemptions are actually checked twice before blocking, so that your trusted sources aren't accidentally locked out. For example, I used to play around with the middleware, checking how security works, and on a lot of occasions, I actually ended up being blocked. So I had to put myself in the whitelist. Um, and We have a centralized manager instead of just using Django models. And the main reason for that is that the support right now is for Django models, but the goal is to extend that to CSV or JSON. Um, but that's for upcoming version updates. So in this one, the path is tokenized into keywords. So these tokens are checked against both static suspicious keywords and dynamic learned ones from traffic. Now, the main thing here, if a token matches and it's not really exempt, the request is blocked. And to give a more idea on how that really works, is that the middleware automatically recognizes what keywords are actually safe in your project. It extracts them from Django routes, apps, configs, and model names, and explicit settings, and a common set of also default safe terms are also included. So context makes all the difference. So a lot of times your keywords are actually SQLI or XSS signatures, or maybe directory traversal attempts or suspicious file extensions, and hidden file probes. If a pad does not exist in Django, that's only when it's treated as actually suspicion, because we don't want to end up blocking legitimate traffic. Now, the idea is not just to rely on static rules, it also learn from what attackers are probing for. So, like I said, the tokens are only collected from failing requests like your 404 or 500, basically non Django paths, and counts how often they appear. So, the top tokens are added automatically to the keyword store, or maybe in this case, since there's only Django's model support, to keyword model. That way, if attacker starts scanning for maybe PHP myadmin or backup.zip, AI WAF blocks them immediately without any manual updates. Now, preventing false positive is just as important as blocking attacks. The main thing to notice here is that, and a key part of this is that it automatically gets all the keywords from your Django apps or routes, and as well as model names, to make sure that any legitimate users that probably look suspicious and maybe it's just a quirky user doesn't end up being blocked. So now the main reason for that is this keeps protection strong without actually breaking real traffic. Now, this also includes now another middleware is rate limiting. So, the main way that this actually works is that it tracks requests from each IP within a short sliding window, and if a request actually passes a soft limit, let's just say maybe 9 requests, the user gets a warning that hey, there's too many requests. But if they cross that threshold and ignore that, then the IP address is blocked entirely. Now, because it runs off of Django caching system, it's very fast and can work across multiple servers, making it very effective for stopping brute force logins or DDoS style burst. So how it actually works is that each IP has a small list of timestamps stored in cache. For every request, we remove the old entries and append the new one and save the list back. That's pretty much it. And that lets you check volume over the last n minutes. N is most commonly 5 minutes. And then we apply two thresholds, one for soft limits that triggers a 429 and another for floods that triggers an outright block. Now, this is very efficient because most of the time the list stored in cache is just a handful of entries. Now, all these thresholds are configurable in Django settings. You can tighten them up for maybe sensitive routes like login and maybe loosen them for APIs, because a lot of times if you apply this on APIs, then a lot of maybe web-based applications will end up being blocked because it would look like a DDoS style attack. But because it runs exactly through Django cache, it works through whatever cache backend you're using, probably Redis. Um, and as always, in every single middleware, exempt IPs and views are ignored completely, so you can tune this without breaking trusted traffic. So now this middleware is where AI really comes into play. And before we dive in, what this actually does is that it uses machine learning, like the name implies, to look at traffic patterns and to decide what is normal and what is weird. And the model is an isolation forest, which in short terms it means it's unsupervised, so you don't really need labeled attack data. And a main thing of what the parser does whenever you train the model is that it creates a new data set, kind of, which creates a list of feature vectors like maybe path length, how whether it contains bad keywords, how fast it responded, status code, how many requests are in that burst, and how many 404s we have seen from that IP. Now, if the model says that it's anonymous, then we do a few more checks before deciding to block. So now the main thing to notice here is that you don't just want to block just because the isolation for us said so. Now instead, the activity of last 5 minutes are analyzed for that particular IP. Now, for example, if the hits are low, for fours are under 10, maybe bursts are under 15, and total requests are under 100, we treat it as an odd, but maybe it's a legitimate quirky client. Now, but if those thresholds are exceeded, that's a strong sign of malicious behavior, and the IP ends up being blocked. Now, this actually ends up preventing false positives, which are the biggest risk with any anomaly detection. Now, the main thing is this constantly needs learning, and for real time, every request is logged into cache with its time, path, status, and response. This kind of builds up a short-term memory of activity for each IP. Now that data not only powers the logic, but also feeds back into the dynamic keyword discovery. Over time, the retraining the isolation forest model maybe ends up picking new behaviors that weren't really in the original rules. Now, the main thing to know that is not really a static; it adapts as it sees more traffic. Now, I think a key thing to cover also is how what an isolation fuzz really is and how it really looks at data. Um, so, when we basically talk about malicious detection in web traffic, most web requests are basically straws in a haystack. They're most of the time harmless, repetitive, and expected. But instead, we probably want to look for a needle that might be something dangerous. Now, basically, isolation workforce works exactly like a metal detector in this case. It doesn't really tell us what exactly the object is, but quickly flags the unusual ones. Now, instead of checking every straw, we only examine the flagged anomalies. Now, then by our guardrail rules like checking for burst for force or malicious keywords actually helps us decide whether what we found was actually a needle or maybe it was just a straw that looked like a needle. Now, the beauty of isolation for us lies in its simplicity and practicality for web development. Now, unlike unsupervised models, we don't really need pre-labeled data telling us what's actually good or bad. It figures that out by itself. Now, basically, long story short, it works by randomly splitting features until an outlier is isolated, and in a lot of cases, anomalies are actually isolated much faster than normal data, and which is what it makes it very efficient. It also scales really nicely, so we can feed in tens of thousands of traffic logs without a huge performance hit. And turns out, if you have a decent CPU and you don't really even need a GPU for retraining. And as I already implied, retraining is simple, so that should be done based on requirements to make sure that the firewall stays updated as attack patterns evolve. So this is actually the backbone for AI web's adaptive defense. Now, the training frequency. I guess one of the most common questions I got, probably we might get to this later as well, is how often should it be retrained? The simple answer is it depends on the volume of requests that your application handles. If the model actually learns from real world patterns in traffic, so if you have millions of requests per day, then you'll have enough to justify frequent updates. Now, if your site only ends up getting a few thousand requests daily, then training less often is actually fine. So the key thing to know here is that the training frequency actually scales linearly with the number of requests. The more data you collect, the faster the model can adapt to new patterns. For example, an app serving a millions of requests per day probably benefits from daily retraining, whereas a smaller nonprofit that only handles a few thousand requests can retrain monthly. Now, a big thing to note here is that overtraining actually wastes resources, so the best idea is to align the schedule with your actual traffic. Now, the next middleware is honeypot timing. The main goal of this middleware is to watch how users move from a get page load to a post submit. Now, real users take time, but bots often submit instantly or hit the wrong methods. So, when a client calls a method that the view doesn't really support, like if we have a view that only has a uh, get request, but it ends up getting a post request, that's probably a bot. So that ends up getting blocked. Now, as always, exempt IPs are always respected. So if and the method also returns clear responses. So it's either a block or a page or a page expired or an exempt. So now, if let's just say if because it's all built into cache, if a page ends up being idle for more than 5 minutes, this middleware actually ends up returning a 429, asking the user to reload. Now, each GET request is timestamped. In post, actually, there's two things checked. So, does the view actually allow post, and did the user wait long enough? Normal forms need at least a second, but login can sometimes be very quick. so we allow a little less time in there. Now, if the page sat open for too long, maybe over 4 minutes, we don't really block and we just ask the user to reload with the 429 page expired. Um, but for other requests like put delete patch, it's only allowed if the view actually supports them. And the basic goal, the basic thing that this view basically does, this middleware actually does, is that if a method is not allowed by a view, then it's straight outright block. That's a strong sign that someone is actually trying to hack into your website. Now, enforcement is graded. If a client actually submits too fast, then it's blocked outright. And it's 403 for suspicious timing and 405 for wrong methods. Now, if a page is simply stale, then the user is not punished and simply has to reload. Now, as always, exemptions always win. So if an exempt IP ends up playing around with the website, then it doesn't end up being blocked. But the main thing is that the normal request flows through unchanged. Now this middleware basically checks whether if a UUID in its URL and is it valid. So every time a UUID is basically in a URL, it sanity checks before it executes. Now, if a UUID does not result to any real object in a UUID primary key model in the current app, then it's treated as a tampering attempt or an enumeration. Now, legitimate users often hit real objects, but bots, website scanners often spray random UUIDs, and that's the main thing here. If a UUID does not exist, it ends up getting blocked straight out. So the main thing to notice here is that this middleware fires at process view, and the first thing that is read is the UUID parameter, and discover the app for that view, and then scan the models for those using UUID primary keys. Now, if that particular UUID does not exist in any of them, it ends up getting blocked. But if it does, then it's allowed. Now, doing this actually makes sure that your view code is clean, and it saves DB work on invalid objects. Now, a key thing to note is exemptions always apply. So if your internal tools or health checks won't end up getting blocked, but if someone ends up supplying a malformed UUID, we end up swallowing type errors and treat it as a miss. But if there's a large difference, then it ends up being blocked. But in large projects, scanning every UUID primary key model can often be very costly. So you might want to optimize by whitelisting which models you want to check per route or caching the negative lookups briefly. Finally, the main goal of this middleware is to only validate whether a UUID exists or maybe based on that block or allow. But if you want, you can enforce authorization in your view or your query set. Now, onto the middleware logger. So the main thing for this is now as by this time AI WAF all needs data to make decisions. So that's the main goal here. So the logger middleware exists to make sure that AI WAF always has data, even when standard access logs are not available. So every request ends up getting passed through Django through a request log model, and this includes the IP, method, path, status code, timing, and all that user agent. Later, this data is actually used by the trainer, which consumes for building anomaly models. So the main thing to note here is that each entry is rich enough to reconstruct traffic patterns. We log the IP, the method, and the path. We also track how long the request took, the response code, and metadata like user agent and referrer. To prevent storage bloat, long feel like maybe long paths are often truncated. Now, the main goal of this is to convert it to a format that the trainer already expects. So now this supports both string lines and dictionaries in the common log format. This way, you don't have to change trainer logic every single time. It can consume logs just like it would server logs. Now onto the setup. The setup is actually pretty simple. You have to, and I'll go through it step by step. So first thing, you have to install AI WAF into your particular project. Um, and right now it exists as this, and I'm actually focusing on building it for others. So that might change into Django AI WAF maybe in the near future. So then you would have to add it to your installed apps and give it access to logs. And without logs, the at least the AI part would not be able to function. And if you don't have logs, you can add the logger middleware right here. And the main thing is this is very customizable. So let's say if I don't need the AI anomaly middleware, as let's say if you're using a free tier on AWS, probably you cannot support retraining because it's very computationally expensive, and that's something that the free tier cannot support. So you can just remove that from there, and you can still use the rest of the middlewares as it is. The main thing is if the main thing is you don't really need all of the middlewares, but the best advice is if a layered approach would probably provide for the best defense. That's the main thing to note here. Then to store data, AI WAF actually needs models and everything. So you would have to make migrations and migrate to make sure that it syncs with your particular web app and make sure AI WAF is available to run. Now, with that being said, future the future work is basically to make it platform agnostic. Now that means extending support to Flask, Fast API, or Express, or even PHP frameworks like WordPress or Laravel. Now, I think developers shouldn't choose a different firewall based on what stack they're using. The long-term version is a universal WAF that you can plug in into any application with just a single line of configuration. Also, another goal is the intelligence layer. Right now, AI WAF only uses rule-based heuristics with a lightweight anomaly detection. But in future, the main goal is to train deeper models to recognize subtle attack patterns across sessions. Things like behavior fingerprinting could also be very useful. For instance, another example would be instead of just blocking one bad request, the model could detect coordinated probing attempts over time. The challenge in doing this is to not slow down performance. We don't want each request to take more than maybe 35 to 50 milliseconds. So the research is not only about building smarter, faster AI models, but also to also to make it lightweight enough so that it can scale in production. And yeah, like I said, right now it only has me working, but it would probably benefit from getting more contributors. So whether it's starting the repo, reporting issues, writing code, every action helps. And the main idea is that the project gets stronger with every new contributor. So that's actually the website for AI WAF, and I would like to thank DigitalOcean for sponsoring that. Um, and thank you guys for actually listening to me. I hope this was useful, and I can take questions now if you guys want.
Thank you. That was super interesting. Are there any plans to actually pre-train the model on open sources of, like in your repo, it has Nginx logs, right? But what kind of ever access log to actually provide some knowledge of what's already out there? Because one of the biggest benefits we have in the cybersecurity community is that open information sharing, right? So as opposed to training individual models, actually sharing those, either the Nginx training data or actually sharing the models themselves. Did you have any kind of plans or thoughts around that?
Yeah, actually, there's actually a pre-trained model already available. But the main thing to note here is that that's only trained on 6,000 lines of log data. So it's a good start, but it's not. I wouldn't say that it's a big jump to retraining. But that's why I actually implied on retraining and everything. But I have a few plans on probably either building synthetic data around that, but it's really hard to kind of model real world behavior in synthetic logs. So that's another challenge, but I am actually exploring on that.
Yeah, hi. Do you have any intentions of supporting Django channels or WebSockets with this?
I haven't thought as far as WebSockets, probably because I am not very comfortable around them, but I'm learning them and everything. But I guess the closest thing would be the APIs, right? So right now, what I was focusing on was including encryption methods with the IWAF for encrypting the path. The main challenge is to build basically two packages around that. First, that you could use from your application to maybe the API application to make sure that the line is encrypted. But in terms of WebSockets, I guess I'll have to read more around that and kind of figure out how I would design it to be more compatible with that and everything. Probably another middleware. But yeah.
Thank you.
Okay, so thank you, Ayush, and please give again a warm